You know, I've been a back-end architect for well over 15 years, and believe me, I've seen some things. I'm talking about data that just vanishes into thin air, and entire systems that just crumble under pressure. Today, I'm going to share one of those war stories, a story about something I call ghost money, and the one single annotation that could have saved the day.
So I want you to picture this. It's 3 a.m. The on-call pager is screaming. A high-value transfer, $50,000, has just disappeared. The money is gone from the sender's account, but it never ever showed up at its destination. You've got ghost money. And what's worse, you've got a catastrophic data integrity failure.
So, what in the world went wrong? Let's do a little postmortem, shall we? We're going to perform an autopsy on this failure and dive right into the code that caused this whole mess.
And here it is. This is our villain, the transfer without transaction service. Just look at the sequence of calls here. You see that account repository.save and flush for the source account, and then later another one for the target account. Each of those save calls is its own separate, isolated conversation with the database. They're completely independent, totally unprotected actions. And that, right there, is the root of our entire problem. Let's trace the exact path to disaster, step by painful step. First, we find the accounts. Easy enough, no problem. Second, we debit the 50 grand from the source account, but just in memory. Still okay. Third, we save that updated source account back to the database. And right at that moment, the money is officially gone from the sender. And then, bam, the system crashes. Maybe it's a network glitch, a server reboot, who cares? The point is, the code to credit the target account, it never even had a chance to run. The money's just gone. To stop this from ever happening, we need a shield. We need a way to guarantee that our debit and credit operations are treated as one single indivisible unit. And in the world of Spring, that shield is the @transactional annotation. This really lays it all out, doesn't it? Without transactional, you're essentially making two separate, risky bets. First, you bet the debit will succeed. Then, you place a whole new bet that the credit will succeed. If either one of them fails, you're left with a complete mess of inconsistent data. But with @transactional, you're making one single safe bet. The debit and the credit are wrapped together in an atomic unit. If any part of it fails, I mean, even the very last step, the entire operation is rolled back as if it never even happened. The debit gets undone. It's truly all or nothing. Now, that sounds pretty amazing, right? Almost like it's magic. But you and I, we're engineers. We know there's no such thing as magic in software. So how does Spring actually pull this off? All right, let's pull back the curtain. The magic behind @transactional is actually a really powerful design pattern called aspect-oriented programming, or AOP for short. So when Spring starts up and it sees @transactional on your service, it doesn't just give you back your own object. Instead, it creates what's called a proxy. It's basically a wrapper object that sits in front of your real service. Think of it like a security guard or a gatekeeper. When a call comes into your transfer method, the proxy intercepts it. It starts a database transaction first, and then it calls your actual code. If your method finishes without a hitch, the proxy commits the transaction. But if your code throws any kind of error, the proxy catches it and immediately tells the database to roll the whole thing back. It's brilliant because your code only has to worry about the business logic. Okay, now I need you to listen very carefully because this is the most common and frankly the most dangerous pitfall I see developers fall into. Since this proxy is a wrapper, it can only intercept calls that come from outside the object. What does that mean? It means if you put @transactional on a private method and then you call it from a public method inside the same class, the proxy gets completely bypassed. The call is never intercepted, no transaction is ever started, and the worst part, it fails silently. Your data is totally unprotected and you'd have no idea until it's 3 a.m. and the money is gone. But @transactional is not a one-trick pony. It does more than just ensure atomicity. It also manages your database session. See this fetch type.lazy on the account entity here? That's a classic performance optimization, right? It means we don't load all of a user's transfer history at once. But if you try to access that history outside of the initial database call, the session is already closed and your app will crash with the dreaded LazyInitializationException. Well, @transactional solves this beautifully by keeping that session open for the entire duration of the method call, letting you safely load that lazy data whenever you need it. Okay, so we've covered the what and the how. Now let's put it all together into a simple, practical rulebook for using @transactional effectively and most importantly, safely. So here are the key takeaways.
Rule number 1. Do place @transactional on your public methods, and do it in the service layer. That's where your business logic belongs. Rule 2. For any method that only reads data, use @transactional read-only is true. It's a huge performance hint for the database. Now for the don'ts. Don't ever put it on a controller. You risk holding a database connection open for way too long, which can exhaust your connection pool. And I'm going to say it one more time for the people in the back. Don't put it on a private method. It's a trap, and it just won't work.
And while we've been focused on databases this whole time, this core concept of an atomic all-or-nothing operation is a universal principle in good system design. It goes way beyond just your SQL server.
An all-or-nothing contract is absolutely essential, pretty much everywhere. I mean, think about sending a message to a Kafka or a JMS queue. You want to be damn sure that your database update and your message being sent either succeed together or they fail together. In the world of microservices, complex patterns like Sagas exist for this one reason: to create transactional guarantees across many different services. The principle is exactly the same. So that brings us to the final, most important question. I want you to look at your own applications. What's your ghost money scenario? What's that one critical business operation that absolutely cannot, under any circumstances, be left in a broken, inconsistent state? I want you to really think about it. How can you apply this all-or-nothing principle to make your own code truly rock solid?